Hi students, today we'll be learning about some different special formulas for trigonometry. So to find the sides and angles of non-right triangles, we have the law of sines and the law of cosines. To find the area of non-right triangles, we have the sine formula and Heron's formula. Here's the law of sines, law of cosines, area of a triangle using the sine formula, area of a triangle using Heron's formula. I just put them all together so it's an easy reference page. Also, for this video, I want to clarify that I will not be going over the proofs. I will just be going over examples of how to use these formulas. If you're interested in looking up the proofs to see why these formulas will work, here are some links of the proofs and you can check them out. So for the law of sines, it is mainly saying that the ratio between sine A divided by the side length A and sine of angle B divided by the side length B, sine of angle C divided by the side length C, these ratios are the same. And because the ratios are the same, you can also flip them with the side length on top as numerator and the sine of the angle on the denominator. Also, when you solve these, you don't need all three. You usually just need two of them to solve. More specifically, we use sine on the numerator and side length on the denominator when we try to find the angles. And when we try to find the sides, we use the side length on top and the angles on the bottom. It really doesn't matter, but it just is a little faster this way if you want to think about it that way. Okay? All right, let's try this problem now. We need to find Q, which is a side length. So I would use the side length as the numerator and the opposite angle as the denominator. So Q divided by sine of Q, which is 24 degrees, is equal to, well, I could use R, but there's no angles there, so I'm not going to use R. I'm going to use P, which is 57 degrees, and 10, which is the side length for P. So 10 divided by sine of 57 degrees. Now I will solve for Q and then I will put it all in the calculator. I personally prefer to solve for it first before putting it into the calculator because once you put it in the calculator, if it's a decimal, then you have to round. And if you round too early, your final answer might be off, okay? So cross multiply Q times sine of 57 degrees and 10 times sine of 24 degrees. Now we divide both sides by sine of 57 degrees and we will get Q equals to 10 times sine of 24 degrees divided by sine of 57 degrees. When you put in your calculator or Desmos, make sure you're in degree mode because if not, you will get the wrong answer. Okay, so you can see that I am in degree mode and I put 10 times sine of 24 divided by sine of 57. So because 10 is multiply, you could leave it there or you can move it up on top, up to you. But our answer will be 4.849778431, nearest tenth, so just 4.8. So Q equals 4.8. Now let's take a look at the law of cosines. It is very similar to the Pythagorean theorem where a squared plus b squared equals c squared, but this is a squared equals b squared plus c squared minus 2bc times cosine of a. Just know that whichever angle you're using is the cosine of that angle, the opposite side is what is squared first and on the other side of the equal sign. And you could use this for whichever angle or side is given. So if it's B, just make sure it corresponds with cosine B and C with cosine C. Now with the law of cosines, you could either use the one we just talked about, the standard form, to find the sides, or the alternative form where you solve for the cosine of the angle to find the angles. It's just faster, but you can use both. Doesn't matter which one you use if you don't mind solving later. It's just a little faster. All right, let's try this example. What are we looking for? We're looking for side U. Find U. That's the side length. So we're going to use the law of cosines. U squared equals b squared plus c squared, which is 10 squared plus 13 squared, then minus 2bc. So minus 2 times 10 times 13 times cosine of U, which is cosine of 31. Now we can just put this on our calculators or Desmos to find out the answer. So make sure your degrees once again, and you just type it all in. 10 squared plus 13 squared minus 2 times 10 times 13 times cosine of 31 degrees. You get 46.13. Don't forget to take the square root of that answer, because right now we have u squared equals to 46.13 blah blah blah. We have to take the square root to find u, which is 6.79, and if we round to the nearest tenth, 6.79 will be 6.8. Sorry, the writing's kind of ugly, but that's our answer, 6.8. All right, let's look at when to use which law. We use law of sines when we have two sides and one opposite angle, or we have two angles and one opposite side. We use law of cosines when we have two sides and one included angle, meaning in between them, or we have three sides. Okay. Now off to finding the area of a triangle. This is using the sine formula, half of a times b times sine of c, or half of a times c with the sine of b. Now, how do we get this? Well, remember that the area of a triangle is 1/2 base times height. So A is your base and H is your height. How do we find H? Well, if we use sine of C, it's opposite divided by hypotenuse, and then we could solve for H. Or if we took sine of B, it's opposite divided by hypotenuse, and then we solve for H. We will get these two formulas. So now let's try using it. So in this example, we're trying to find WZ, which is the height of this triangle, and also the area of this triangle. To make it a little easier, I'm hoping to turn this picture so I could see the height as a height, and also 24 as my A or as my base. Now we could just label this triangle. The base is A, which is 24 meters, and the height, which is WZ, which is what we're looking for. We use sine of 55 equals opposite divided by hypotenuse. Opposite, remember, is H or WZ, and the hypotenuse is 21. Now we solve for H, and we have 21 times sine of 55 degrees. Now all we do is type this into Desmos, 21 times 55, make sure you're in degrees, and that will give you H, which is 17.202, blah, blah, blah. Now to find the area, we just take 1/2 base times height, which is A times H. And since we know A is 24 and H is 17.20, blah, 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 when I'm in Desmos, I'll type 1/2 24 times the answer, which was ZW, or the height, because I don't want to round too soon. If you round now and put 17.2, it might make the answer of your area incorrect. So nearest tenth, 17.2, and area nearest tenth, 206.4. All right, let's talk about Heron's formula now. We have a triangle. We have to first find S, which is adding up all the side lengths and then dividing it by 2. And then the area is the square root of S times S minus A times S minus B times S minus C. So let's try an example. Here's our example. We have 3 sides. Let's find S first before we find the area. So 12 plus 20 plus 28 divided by 2. And we can easily find that with Desmos, or you could do it in your head. It is 30, so S is 30. And to find the area, we have to take the square root of S times S minus A, which is 12, then S minus B, which is 20, then S minus C, which is 28. Once again, we could put that into Desmos. So square root of 30 times 30 minus 12, 30 minus 20, 30 minus 28, and we get 103.9 if we round to the nearest tenth. And that's how we use Heron's formula if we're given 3 different sides of a triangle to find the area.